Hello, I am Taylor Brown, and I'm currently doing the first part of Lab 3, which is where we have an RC circuit. I have the RC circuit right here, and I'm using this to generate a step function to my circuit. So I'm doing that, and then I'm measuring across my capacitor with this oscilloscope, and I have measured tau, which is basically 63% of the max voltage value. I've measured that for me to be 76 microseconds, and so then I've just multiplied that times 2, 3, 4, and 5 and found the times. These are all in microseconds that I'm supposed to be measuring at. And I've just kind of gone my way up this curve by switching between the horizontal and vertical lines and then moving them to align with the proper time I want to measure at, and then it will give me the voltage once I move the horizontal line. So I have filled in all of my values right here. I'm currently doing exercise 2, where I'm supposed to construct an RL circuit. So I have my RL circuit right here, and I have it hooked up to my step function generator. It's generating at 1.26 kilohertz. And then I have it all hooked up to my oscilloscope, which is measuring the voltage across the resistor, and I'm going to use that to find the current through the inductor by just dividing it by the resistance. But here's the output I'm receiving. The blue, I know it's kind of hard to see, but the blue here is my input, so like a guideline for where it should be, and then the yellow is like my actual circuit output. So I'm just gonna move cursors along here. First, I'm gonna find tau by finding when the voltage is 63% of the max, which is about right here. So I'll do that first. Okay, now I've measured what 63% of my maximum voltage is, and I found it to be 473. So I've moved my two cursors to where the voltage is 473 millivolts, and I found that the time is 2.44 microseconds. I just finished measuring all of my currents through my inductor up to 5 tau. This right here is where 5 tau is. So this part right here is from 0 to 5 tau. And I've just gone through and moved my cursor and looked at what the voltage is at different values of tau, and then divided it by my resistance of 220. So these are the values that I got for all my measurements. Okay, this is exercise 3, where I have an RLC circuit. I have constructed my RLC circuit here. This yellow thing is my capacitor, and the black thing is my inductor. And then this resistor is my V-out resistance that I'm measuring across. And I'm using my function generator to generate 2.79 kilohertz to my circuit. And I have the oscilloscope connected across the resistor here. And this is the output that it's giving me. Let me focus this. It's just the voltage oscillating as time moves on. And I've moved my secondary cursors, the two dotted cursors, to find my peak voltage right at the beginning. And my BY minus AY is 1.02 volts, which is pretty close to my calculated 1.0265 volt. Now I'm calculating the time for my V out to be 1 over E times the peak voltage. So I've taken my peak voltage of 1.02 volts and multiplied it by 1 over E, and I got 375 millivolts. So I just moved my cursor until it was at about 375 millivolts. It only lets me go between 370 and 380 here for the BY minus AY. So I'm just at 370, and I'm getting a time, the BX minus AX, of 940 nanoseconds.